Hello there, and welcome to the fourth episode of Dev Conversations by SwiftToolkit.dev. We have today a very special guest, Matt Massicotte, who, if you follow in social media and in the iOS and Swift domains, you probably read maybe posts or read some answers from him about Swift concurrency. How are you doing, Matt?
I'm doing great. Thank you for having me on.
Thanks for joining. We have a lot to talk about Swift concurrency today.
Yes.
And yeah, it's the main reason I invited you to be here. Before we jump in, do you want to introduce yourself a little bit? Talk about your previous experience?
Sure. I'm a very long time Apple developer. I started working with Apple platforms before Swift, before Objective-C. I started with C. And that was before Mac OS 10. So I was like developing for classic Mac OS originally.
That's Carbon?
Well, it was the APIs that became wrapped up in Carbon. Yes. But before Carbon, actually. So Carbon was this like compatibility system to allow you to not have to port your stuff to Mac OS 10. But the point is, I've gone through many transitions, and it's been funny actually to see this new transition that's happening in Swift. It's been an interesting one.
Mm-hmm. And you've been at Apple also for a while, right?
Yeah, that was a while ago. I joined Apple right after iOS so right after the iPhone was released, and I worked on the iPhone team. I did performance and power there, so I worked with many different teams, but it was all about like understanding performance and how it relates to battery life, basically.
Mm-hmm. So I assume a lot of low-level stuff.
Almost zero UI, actually. A little bit, but not very much. And then after Apple, I worked for a company called Crashlytics, which did crash reporting, and that product still exists today. It's owned by Google. That was a lot of fun. I learned a whole bunch about that. That was an experience up until that point, I had done almost all had been development on Apple platforms. And that was the first time when I really got interested in and had the opportunity to do back-end work. So that system had like a very complicated back-end component to it.
Yeah, I assume, because it involves DSIMs and processing crashes associated with specific DSIM files.
Yes, right? That's right. Yeah, and Crashlytics was a very popular, I probably still is actually a very popular service. So it processed an enormous amount of traffic. And so I got a chance to see like a very big scale for a backend. That was really cool. And there was many languages in there. I worked with Ruby and Go and Java. I did a little bit of Scala because for a little while, Crashlytics was owned by Twitter, and Twitter used an enormous amount of Scala, and that was really cool to learn about as well. So I got exposed to all kinds of stuff there. And then I kind of went off on my own to work on some of my own projects just to like experiment. And I ended up getting more and more interested in doing open source work. And while I was doing open source work, which has been fun and which I continue to do a lot of, just kind of like accidentally, I started discovering that there was an opportunity to do work with consultancy, just like work with it started very small, working with small people. Some friends actually is how I got started. And I just became got really weird specialization in Swift concurrency. And so now that is what I do. Like probably 80% of my time is related to doing consultant work for either people adopting, having trouble with, or just general concurrency work.
Yeah. Yeah, a lot of people, when they have questions on Mastodon, they mention you, right? You became a reference.
Yeah.
But how did you get there? Like how was the process of learning? And
complete accident. It was everything about it was a total accident. I have this policy, just because I've had trouble in the past, that in general, I don't adopt a new Apple technology until it's been out for at least a year. And so I had never used the async await keywords in any other language before. I had no idea how this system worked. And so I waited. I waited about a year. And I was working on one of my open source projects, and a component of that was this public API. And I thought, well, I'm building a new public API. Everybody seems to be talking about async sequence and async await, which I know nothing about. So I might as well try them. So I started trying to learn. And I did that, and I felt like things were going okay. But as I began putting them more and more into
Surprise.
the application. Yeah, exactly. As I started using them more and more in the application, I started running into an enormous number of problems. And it was over the course of me realizing that I actually didn't know what I was doing. It's very easy to use Swift concurrency wrong. It was so easy. It's almost the default is to use Swift concurrency wrong. And I started trying to understand how it works for real. And as part of that, you discover that you can like turn on these warnings that are off by default for some reason. And you turn them on and then you realize, wait a minute, I don't even understand what the warnings mean. And through that process of learning, I wrote a couple of blog posts about it. I ended up getting really lucky. And I got connected with the Swift compiler team. And one of the contracts that I did over the summer was to write the Swift 6 migration guide for Swift.org.
Oh, well.
Yeah,
Okay.
so that was like a close collaboration with the compiler team.
We will leave a link for that. I wasn't aware of this guide. And
yeah, so there's this big migration guide, and a significant portion of it I wrote.
Mm-hmm. Very cool.
Yeah, and that's become a thing now.
So I was watching also your talk where you talk also about these problems that they are in a scale of how do you define that? Scariness?
Fear level, yes, yeah.
Yeah, fear level, and things there can get very complicated, and that's why I feel that doing simple try await stuff and writing async functions, that's easy. But once you start digging deeper or having more complicated scenarios, then they get really complicated, and that's why I have mixed feelings about struct concurrency, because it's amazing when you start using it. It makes things so much simpler to write code, and it's much more readable and everything. But if you don't know what you're doing, you can get in very bad shape.
And I don't even understand how anybody could know what they're doing. Because the compiler feedback is all off by default. If you just start experimenting with these things, or you do some Google searches and you find some blog posts about how this stuff is supposed to work, it's very easy to find information that's based on an understanding without any compiler feedback turned on. And so it can feel, and this is what happened to me, it feels easy to get started, but it's not easy at all. And you said you had mixed feelings about it, and I think that's correct. That's the correct feeling to have. You shouldn't feel, I think some people feel extremely negative about Swift concurrency, and it makes a lot of sense because it can be very hard to take an existing project and migrate it to the Swift 6 language mode, for example, can be impossible to get to for some projects.
Yeah.
Even just understanding, forget going to the 6 language mode, just understanding some basic usage of it can be very, very challenging. You said that it can be simple in simple cases. I don't even agree with that. I think that it can be quite hard to use, even for very, very simple uses.
Yeah.
Now, that said,
that makes sense.
I will add that I don't think that locks and queues are easy to use either. In fact, the more concurrency consulting I've been doing, I've been running into so much code that uses locks and queues that is totally wrong. I mean, completely wrong in every possible way.
And the advantage is that with Swift 6, we have that at the compiler level.
That's right. Yeah, so you're getting this compiler feedback. It's happened with my own code too, that I've migrated quite a bit of my own stuff from using more traditional synchronization primitives to concurrency. And I thought this code was correct. And as I was doing this, I discovered that I really did have some problems. And it wasn't the compiler wasn't making my life difficult. What was making my life difficult was I had bugs. And the way that I had organized and really architected the system was never going to work properly. And so it's painful to get that.
So how did you solve it? How was the process for? Because we said that mixed feelings is legit, and I think it's part of the process where we feel we understand, then we realize the mixed feelings come when we realize we don't.
Yeah.
And how you bridge this gap?
Well, I think the feelings come from frustration about understanding there's so many tools in the language. The language has expanded in an enormous way over the past 2 or 3 years. So one part is just frustration. How do I learn how all these things work? And that is hard. I talked about this migration guide, and it covers large portions of how the language works, but it doesn't cover everything. And also, it's not stopping. There are additional things that it's gonna keep changing.
Yeah.
I don't think it's going to change in dramatic ways for the most part, but just learning how does everything work is hard. So that's one source of frustration. And then another totally independent one is, how do I take the code that I have right now, and which I believe works correctly? How do I take that code and move it into, let's say, the Swift 6 language mode, error-free? You can't even compile when you do that. And most of the time, what I talk about with teams is, why are you doing it? What is the motivation for you to move from where you are now? You have a working application. You have other projects, things that you want to do that are not related to just making the compiler
Why
happy.
do you want to spend your time on this?
Right. And so it could be that you are very concerned you have real races. Maybe these real races are impacting your users. And I'm working with the team now. They're very concerned about race conditions. They have, and we have identified an enormous number of real races in their code. How can we address this? And the problem is intractable. Without compiler feedback, it will never happen. We will never be able to get a handle on these problems. And that's the reason why they're so excited about using Swift 6 to do it. But that's not every application is in that situation. You might have a working code base. I don't know why you would migrate to Swift 6. I tell many people, don't do it. There's no pressing need to do this. Maybe you have a reason why. Maybe you want to start a brand new module with a small amount of functionality and you want to turn Swift 6 mode on for that particular module. That does make sense. But to spend time, especially if it's hard, to spend so much time migrating your code from where you are now to the Swift 6 language mode, you have to have such a good reason to do that because it could be very hard to do.
Yeah, but for those teams that do decide to move and they have large projects, what are the tips you usually give? Where to start from?
If you have a large project, hopefully you also have a lot of modularity.
Modules. Yeah.
And there's a lot of tools in the language to control what kind of warnings you see up until the language mode is also per module. So if you have a big project with a lot of modules, one module at a time, that's what you have to do. And it's tricky because I don't think there's a universal solution. I've had pretty good success with kind of like bouncing around between I'll make some change and I'll realize, oh, I need this struct to be sendable and this type has to be main actor. And then I'll make those changes and then I'll reevaluate where I am. And sometimes that can involve changes in multiple modules. But usually, I don't think there really is one strategy, especially for bigger projects. You're talking about having many teams or many developers. You're going to have to tackle it module by module. And those teams that are doing this work, they will have to understand more deeply how the language works the further away from the UI you get. If you're working purely from like Swift UI or UI kit and you're very much at the top level of the application, for the most part you're thinking main actor or not main actor, and almost everything is going to be main actor. It can be easy.
Yeah.
But as soon as you start building libraries or going into deeper systems, these will be more complicated. They won't necessarily work only on the main actor. And then you have to understand some of these maybe more complicated language tools to build the APIs you need to build.
Yeah, makes sense. Yeah. And I assume that starting from a lower level, like from a more core framework, that would affect every framework that depends on it, or not necessarily?
It depends what the changes are. For the most part, there's a poorly understood tool is the preconcurrency annotation, but it is really useful for this particular operation where you have some core library and you want to add some annotations, but you don't want to force, this is what's important, you don't want to force clients to then have to update their stuff as well. And so preconcurrency, this is what Swift UI uses. Swift UI annotates its view with main actor, but it also puts preconcurrency, which means if you're using concurrency warnings or Swift 6 mode, I will enforce those annotations. But if you're not, if you're just a regular Swift 5 user with warnings off, you'll see nothing. And so those tools can be really useful for you to introduce. I always think about it as introducing truth into your code base. Like this callback always happens on the main thread. Put the annotation, main actor on there. But then also put preconcurrency so that if there are clients that don't want to see this warning, they don't see them. Yeah. But expressing the reality of your code base is a component of adopting Swift concurrency. And usually you can do that without too much pain in the rest of the code base, unless you have to do something like maybe make a new function asynchronous. That can be a very painful thing to do, especially at a lower level.
And there's also the preconcurrency when you do the import, right?
Yeah, preconcurrency is so tricky because it has like two different meanings depending on whether are you using an API, and if you're the consumer, then you use maybe a preconcurrency import. If you're the vendor of an API, if you're making it, then you can annotate your own stuff. So it's all related, but it has two different uses. That's another strategy that people will take. Is some people's idea is, I want to take my existing code base and make the minimum number of changes, but I want to go to Swift 6 language mode. This is very hard to do, but if you really want to, you have to get good at using preconcurrency to be able to suppress warnings that come around. And the trade-off is then that's an even harder justification. Why are you using Swift 6 when you're turning off all the compiler feedback? You're telling, when you're using like a preconcurrency import, you're promising the compiler, the way I'm using this API is exactly correct. But that might not be true. And now you've turned all the warnings off, so you have none of the feedback.
Yeah, you'll gain nothing, basically.
I don't know if I would say nothing, but I think it's...
Yeah, but basically you enable and then you quietly disable. It's like adding a linter and disabling it.
Yeah, that is exactly what it's like, yes.
Yeah. Okay, and while watching your talk in the Toronto conference, Swift TO, you mentioned a few packages that you wrote to help some challenges about Swift concurrency. There was main offender and queue. What do they solve, and how do you feel about the language missing things like this?
Okay, so I'll start with main offender because it's an interesting one, because that's actually was a primary part of that talk, was discussing how you might go from an existing project that's using dispatch queues to make them warning free in the Swift 6 mode. And I mean, that talk didn't age very well because a lot of the things that I discussed have since been addressed by Apple by annotating their APIs more correctly. Yeah. Okay. And so the original reason I made that package, main offender, was because I just found it incredibly frustrating to have to constantly add these things to my code base. But they've done an okay job, I'll say, of updating the language and the frameworks to be annotated and understood such that it's relatively easy to use these things. Like some of the code that I presented in that talk now can be error-free. In fact, it's actually amazing how much you can get error-free in Swift 6 with a Swift 6 compiler. It's pretty incredible. But they didn't do a perfect job, right? Because there's some very large, important APIs. Like, I'll give you an example, is operation queue. I don't think it's in that wide use now as it has been in the past. But operation queue received very little updates, and it didn't match the updates that were done to dispatch queue, for example. And so I, at the time, used operation queue a little. I hadn't quite removed it completely from all of my code base. At one point, I used it a lot. And so I added just a few little helpers to be able to move towards being warning free with operation queue. But what I discovered as I was doing this was I didn't want unsafe opt-outs. My goal, I didn't want to continue to use these tools that turned off the warnings. Like, my goal wasn't, I don't want no warnings, I want no races. And I want to be able to understand the language to achieve that goal. And so over time, that package has kind of evolved from being a way to turn off warnings to just a few targeted tools to be able to temporarily deal with situations that Apple doesn't give you tools to otherwise address. There aren't that many, but there are some important ones. For example, run loops. I've interacted with a whole bunch of APIs that are run loop only. I mean, a common one is NS-Timer. NS-Timer is probably used by so many applications. Yeah. But it integrates very poorly with Swift concurrency. I don't think there's too many other commonly used APIs that are run loop only, but you might need a tool to deal with that. And so if you do, then Apple provides nothing. I think the problem that I have heard of the most, anyways, from people is Combine. Combine is this API that was used extensively by many, many, many projects, and it received basically no annotations at all. And I was surprised by that.
Yeah, which is all the point of Combine is dealing with streams and synchronous stuff.
Yeah, and I understand too that the way that Combine models concurrency is not really possible to express purely using the type system, which is what Swift concurrency does. So you can't really, and this is similar, like dispatch queue, Combine, that have the same thing where the runtime state, it really matters for how things are going to execute. And you just can't model that correctly with Swift concurrency. So they needed to provide some sort of tools to deal with it, and they have. That's what this thing called dynamic isolation is all about. It's a way to write in your code, I know the compiler can't see how this is going to work, but I'm going to promise you that this is the way that it works. And the compiler will then just verify at runtime that you've made correct promises. But it's really hard to do that and even understand what's going wrong if the APIs you're using aren't correctly annotated. And Combine is not. So Combine is missing all kinds of important annotations. And these have really terrible consequences for your application.
Consumers.
Yeah, if you start adopting Swift 6. I don't really have any good solutions to this one. I think that I'm not sure what to do about this. You have to be aware. If you're, and this is the thing really, you asked me before about like adopting Swift 6. I think this is one of the things where you've decided as a team, we're going to adopt Swift 6. Part of that decision is, and we are going to take on adopting a technology that's a major language change in the first year that it's been introduced, when we know not all of Apple's APIs have been properly migrated. You're taking on a lot of responsibility by doing that.
Yeah. Yeah, it's not an easy choice. I think that these problems, they can be divided into Apple platforms, which have zero influence, and there's the language domain, which we could, like, in theory, you could draft a new proposal that could maybe address dispatch queues issues, right, instead of the package.
Well,
is this something you thought about it?
You're right. The language can be changed. And I think really it becomes down to understanding the problem. Is the problem, like for a dispatch queue, for example, like, can we design a language feature to make this work? Is this API possible to describe purely in compile time? And
that's a better way to describe my question.
Right. And so you're totally right that there's so many language tools that exist today, or maybe new tools that don't exist yet that could be changed. But there are limitations in like the fundamental designs of what it's possible to describe using the type system. And that Swift concurrency is all about the type system. That is how it works. And so there are some things, I mean, for example, if you look at the async function of dispatch queue, is that async going to happen on the main thread, on a background thread? What thread will it happen on? And it depends on what queue instance at runtime you're running it on. And so that's not really something you can possibly model with the type system. And so I don't know that there exists a language feature that could be added that would address certain kinds of problems. Combine has exactly the same thing. I don't know that there is a language feature that could be added to address that problem.
Yeah, no guarantees.
Yeah, it's just not describable using the type system there. But separating it out, I think, is really good, is to think about, what are the language problems? Are there language problems, maybe? I mean, many people ask, a very common question is now a good time? Should I do this now or should I wait? Maybe there's new language features that are going to help make this stuff easier. And there is. In fact, there's a really handy change that's coming around. I don't think it's going to make it for Swift 0.1, but soon-ish. Soon on the scale of language changes that will make it easier to deal with deinitialization, which has been a problem for some people. How deinit works. But most of the problems people are facing are related to how the concurrency is architected in their application, or missing annotations or APIs in Apple's frameworks. And Apple is making progress on that. I mean, even the difference from Xcode 16.0 to 16.1, they fixed a whole bunch of problems with WidgetKit, for example. And WidgetKit is a very commonly used API. It was missing all kinds of annotations everywhere, very annoying to use, and now it's much better. And if you are using an API that you have trouble with, filing feedback is super useful.
Yeah, that makes sense. And it's fair to assume that new frameworks, they should be annotated correctly. or not so
I think
much?
it's fair to assume that, but I don't think that it's the reality all the time.
Okay, yeah.
I believe there was, I mean, I'm having trouble remembering what it is right now, but I'm pretty sure there was a new framework added in iOS 18 that had no concurrency annotations.
Yeah, I think that every case is a different one and needs to be, you spoke about it before, right? That you must have a good reason to do it now, and if you're in no rush, then maybe it's better to wait. It's one thing I didn't know is that it's opt-in. It's totally opt-in. Even if you are using Swift 6, you don't need to opt in to the Swift 6 strict concurrency mode.
Yeah,
Yeah,
it's so confusing because there's the Swift 6 compiler and then there's the Swift 6 language mode, and they are independent of each other, sort of.
yeah,
And it's so confusing because many people thought typed throws was this feature that came around with the Swift 6 compiler, and it was exciting. It's a really cool feature, and it enables all kinds of neat things. And many people thought, but I can't use typed throws until I adopt the Swift 6 language mode, and that's not true. You can use type throws, which is a Swift 6 compiler only feature. It's totally fine to use that with code that has absolutely no concurrency stuff turned on.
concurrency. Yeah, interesting. All right. So we discussed a lot of some hard concepts to understand, and we could go on for hours discussing about them. But I think that to really understand, you need to sit and look into your code and learn about these concepts and read about them. You mentioned the migration guide as a good resource. What other resources do you think you could point people to?
Well, something that I have used personally a lot is the Swift forums. They're really great because there are many questions that have already been answered there, but people are very happy to answer the same question again. There's a lot of people that know exactly how the language works, including the engineers who work on the compiler themselves. Yeah, they're there all the time. And I think it's a really, really underutilized resource. So it's not great for asking, it's not the place at all for asking about API specific questions, but for the language and the standard library, it's a wonderful place to get information.
Uh-huh. Nice. I'm gonna also add a link for there was a talk in Swift Connection 2 months ago in Paris
Mm-hmm.
from a guy named Muradli, where he defines a lot of these concepts: is isolation, domain, sendable, preconcurrency. He goes beyond the basic try away, tasting glad things that people when they start scratching the surface of Swift concurrency. So I'm gonna leave a link for that as well.
That sounds great.
I'm also gonna link to your talk and to your blog, obviously, because you have some great posts there. If people want to find you, where do they?
You can check out my blog, which is massicotte.org. There's links there to find me on social media. You can also email me if you're just looking. People ask me for questions about concurrency. I'm happy to help. So reach out to me however you want, and I would love to hear from people.
Yeah, and if people on Teams they want to schedule some consultancy time with you, also by email.
Absolutely, that's something I do. If you want more formal help, I mean, just small questions, I'm happy to just answer them. But if you want something more dedicated, then totally reach out to me and we'll schedule something.
All right. Awesome. Thank you so much. Thanks for your tips.
Thank you for
It was
having
great
me.
having you here.
Yeah.
And we'll see you online solving doubts
Absolutely.
about Swift concurrency.
Absolutely. Thank you very much.
Thank you so much.
Okay.